Hello everyone, I am Chaitanya S. from Sri Venkateshwara College of Engineering. The subject is Principles of Programming in C and the topic is Structures and Unions in C. This presentation explores the concepts of structures and unions in C programming, focusing on their definitions, usage, and key differences. Introduction to structures in C. Organizing data. Structures allow you to group variables of different data types together under a single name, providing a logical structure for related data. Real world analogy. Think of a structure like a file folder containing information about a person, including their name, age, address, and other details. Defining and using structures. Defining the structure. Use the struct keyword to define a new structure type, followed by a structure name and a list of member variables. Declaring variables. Declare variables of a structure type using the structure name, similar to declaring variables of other data types. Accessing members. Access individual members using the dot operator, combining the structure variable and member name. Structure declaration. A structure is declared using the keyword struct followed by the structure name. All the variables of the structure that are declared within the structure. A structure type is generally declared by using the following syntax. And here below is given a syntax and an example for a structure. The variable of structure student can be defined by writing struct student1, and the struct student is a data type and student stud1 is a variable. In the following syntax, the variables are declared at the time of structure declaration. Initialization of structure. Initialization of structure means assigning some constants to the members of the structure. When the user does not explicitly initialize the structure, then C automatically does it. For int and float members, the values of initialized to 0 and char and string members are initialized to 0 by default. The initializers are enclosed in braces and are separated by commas. The general syntax to initialize a structure variable is as follows. And here below is given a syntax and an example. Introduction to unions in C. Shared memory. Unions provide a way to store different data types in the same memory location, allowing for memory optimization and flexibility. Data type overlap. Only one member of a union can be used at a time, as all members share the same memory address. The size of the union is determined by the largest member. Defining and using unions. Similar to structures, unions are defined using the union keyword followed by the union name and member variables. Member access. Members of a union are accessed using the dot operator just like structures. Data type management. You must keep track of the data type currently stored in the union and access only the corresponding member. Declaring a union. The syntax for declaring a union is same as that of declaring a structure. Again, the type def keyword can be used to simplify the declaration of union variables. The most important thing to remember about a union is that size of a union is the size of its largest field. This is because a sufficient number of bytes must be reserved to store the largest sized field. Initializing unions. It is an error to initialize any other union member except the first member. A striking difference between a structure and a union is that in case of a union, the fields share the same memory space, so fresh data replaces any existing data. Look at the code given below and observe the difference between a structure and union when their fields are to be initialized. Differences between structures and unions. Data storage. Structures allocate separate memory for each member, while unions share the same memory location. Member access. You can access all members of a structure simultaneously, but only one member of a union can be used at a time. Memory size. The size of a structure is the sum of its members' sizes, while the size of a union is determined by the largest member. Here is a brief differences between structures and unions. Structure. The struct keyword is used to define it. Union. The union keyword is used to define it. Syntax of structure. Struct name, flower bracket, data type variable name, again data type variable name, close flower bracket. And this is the syntax of union, and example followed by the syntax of structure, and this is the example of union. In structure, the variable of structure student can be defined by writing struct student stud1. um, a variable of union student can be defined by writing union student stud1. Several members of a structure can be initialized at once. In union, individual members of a structure can be initialized one by one. In structure, each member within structure is assigned unique storage area of location. The members or fields share the same space, or fresh data replaces any existing data in unions. The size of structures is sum of all members of or fields. The size of the union is the size of the largest member of or field. Altering the value of a member will not affect other members of the structure. Altering any value of a member will alter other member values. Memory allocation and layout. Structure layout. Structure members are allocated consecutive memory locations, typically in the order that are declared. Union layout. All members of a union share the same memory location with the size determined by the largest member. Padding. The compiler may add padding to structures and unions to ensure alignment and efficiency. Accessing members of structures and unions. Dot operator. Dot operator is used to access individual members of structures and unions. Structure variable. The structure or union variable name is placed before the dot operator. Member name. The member name is placed after the dot operator. Practical use cases for structures and unions. Data aggregation. Structures are ideal for grouping related data such as student records, employee details, or geometric shapes. Memory optimization. Unions can be used to save memory when you need to store different data types in the same location, such as storing either an integer or a floating point number. Flexible data representation. Unions allows us to work with different data types in the same memory location, making your code more flexible and adaptable. Conclusion. Organization. Structures help organize data by grouping related variables, enhancing code readability and maintainability. Flexibility. Unions provide flexibility by allowing you to store different data types in the same memory location. Efficiency. Unions can optimize memory usage, which is important for resource constrained applications. Thank you.